let's try and understand where this formula comes from. So this formula allows you to sum up all the terms of a geometric sequence. So here a geometric sequence is when you times by a common ratio each time. So here you see times 2, times 2, times 2, and so on. So we are trying to sum up, Sn represents a sum of everything up to the nth term. So the trick to understanding where this comes from is to multiply everything here by r. So r Sn equals times this by r, that would be ar, times this by r, this would be ar squared, times this by r, this would be ar squared, ar to the power 3, and then it would be dot dot dot, and then the last one would be times this by r, this will be arn. So now get the top equation, take away the bottom one. So that would be Sn take away Rsn equals, well, if you get the top one, take away the bottom one, you can see that these two, they will cancel each other out. These two will cancel each other out. And these two will cancel each other out, and so on, and so on. So what you will be left with would be a, and then plus the very last one, which would be a r to the power of n. So now a is in common, factor out the a, so that would then be, on the left hand side it would be Sn minus Rsn equals, factor out the a, so that would be 1 plus r to the power of n. And then now you can see that factorize the left hand side, Sn and Sn, so that would be Sn bracket 1 minus r equals the right hand side. And then now you want to get Sn on its own, because Sn represents a sum of all the terms. So divide by 1 minus r. So that would be a bracket 1 plus r to the power of n divided by 1 minus r equals Sn. And that's where this comes from. Just note that r cannot be 1, because it's kind of meaningless. If you have how can you have a geometric sequence where you time each one by 1 times 1 times 1? It doesn't make sense. So just bear in mind that r cannot be 1. Okay, so that's where our formula comes from.